We're now in the EX13 project in the Java 8 folder in my GitHub Live Lessons repository. And we're going to take a look at another example, and this is going to demonstrate various uses of Java Spliterators and streams, both sequential and parallel streams, to traverse each word in a list containing a famous quote from a famous Shakespeare play. So let's go ahead and take a look at the main program. You can see here we create ourselves a list of strings, which contains a famous bard quote, William Shakespeare quote, that was said by Polonius from the play Hamlet. And Polonius is giving some advice to his son Laertes, and he says, "This above all, to thine own self be true, as it must follow, as the night the day, thou cannot then be false to any man." What's particularly ironic about this quote, of course, is that Polonius didn't really follow his own advice, but that's another story. So let's go ahead and take a look at the various examples we're going to show here. We're going to show how the try-advance mechanism works with Splitterator. We're going to see how the try-split mechanism works with Splitterator. And then we're going to take a look at a couple of different examples creating sequential and parallel streams using various techniques. So first, let's take a look at try-advance. This demonstrates how a Splitterator contains a method known as try-advance that's essentially used to iterate through a stream sequentially. And this is very much reminiscent of Java iterators. If you're familiar with Java iterators, you know that they have a has next and next method that are used to advance through the iterator. And try advance is basically a combination of has next and next bundled up into one method. And so the way try advance works is you give it a consumer, it will do something if there's anything left to consume in the Splitterator, and when you're done, it'll return false. Otherwise, it returns true to say keep going. So here's what we're going to do. We're going to take our list of barred words, the quote, and we're going to apply the Splitterator factor method. This comes with all the built-in collections in Java, and that's going to create ourselves a Splitterator for strings, and then we're going to simply advance until we don't have anything else to advance, and we're going to display the strings in the Splitterator one at a time. So we'll see when we run the output and look at what it looks like here in a second, what we get as the display, but it's very straightforward. Let's now go ahead and take a look at show try split. This demonstrates a feature in Splitterators that is not commonly used in a program like this, other than just to demonstrate how it works, but instead it's actually used by the Java Parallel Streams framework when taking a data source and splitting it up into chunks for use with a parallel stream. So here we're going to kind of use it in a smaller, more humble way. We're going to create a Splitterator called second half, and I'll explain why it's called second half in a moment, which takes the original list of strings, the quote parameter, and uses that Splitterator to split it, to create a Splitterator that will cover the entire range. We then take the local variable called second half and apply the try-split method to it. And what try-split does, it will essentially split the array list underneath into two halves. The second half is the part that covers everything from the middle to the end, those parts of the words. And the first half will cover from the beginning up to, but not including, the middle. And so in that case, we've now created a first half that covers the first part of the elements in the quote list, and the second half covers the second part. And to demonstrate that it worked properly, we then go ahead and use a helpful method on Splitterator called for each remaining. And so for the first half, we go ahead and display all the elements in the first half of this range that we split using for each remaining plus this display method, which we'll look at in a second. It just, think of it like println that puts the thread ID as part of the print, so you can tell what thread was used. And then down here, we use second half for each remaining to display the rest of the elements that came from that particular quote list. Now, again, you wouldn't typically use try-split in a program other than to demonstrate how it works. It's used by the streams framework internally. Let's take a look at a couple of other interesting methods. So here we have something that's called show stream. We'll look at this first. Show stream demonstrates how the stream factor method on a collection, like a list, can be used to implicitly create a sequential stream. And what happens here is when we say .stream, that goes ahead and does some magic, which we can actually look at here. If you take a look at the collection, stream, if you take a look at the stream method in collection, you'll see it calls stream support stream, passing in the results of the Splitterator for that collection, and false, meaning make this a sequential stream. And then we go ahead and display the results. And once again, we'll see some interesting differences when we do the sequential versus parallel stream here. The next method we're going to look at is show parallel stream. And this is going to call the .parallel stream factory method to make a parallel stream. And then we will use the for each terminal operation to iterate through that. If we go look at the parallel stream implementation, you can see in the collection class or the collection interface, it will go ahead and use the stream support method, stream support.stream method, to make a parallel stream by passing in true instead of false. So that's how a parallel stream gets made. And just for kicks, up here, we have another method called show stream support. And this just demonstrates that if you're so inclined, you can call the stream support.stream method in your application code. And this particular example just goes ahead and makes a sequential stream, and then we print the contents. Just kind of showing that you don't have to rely on what's provided by the stream and parallel stream factory methods. You can make those calls yourself. Not a common thing to do, but if you're doing something that involves your own splitterators, you may want to do that for various reasons. So now that we've gone ahead and shown the code, let's show what happens when we run the code, and you'll see it'll compile, and then we'll see the results. And the results are a little bit long because I'm putting everything on its own line. But here you can see the try advanced method goes ahead and prints everything out. And you can see that this is what we're going to get there. And then down here, when we do the try split method, you can see that we print out the first half of the splitterator, followed by the second half of the splitterator, showing how it split it nicely in half. If you look carefully, you'll see they're roughly the same size in the first half and the second half. And then we have the stream factory method where everything is in the main thread, that's thread 1. But if you look at the parallel stream factory method, you can see that different elements are printed from different threads in the common fork join pool. So that's just showing how these things are taking place in different threads running in that pool. And then when we do the stream support stream method, that's basically equivalent to doing the .stream factory method, and everything occurs in the main thread, and that's because that's a sequential stream. So that's an illustration of this particular example. It kind of shows some neat features of splitterators, the try advanced method, the try split method, and then shows how splitterators are used to make streams, ultimately by leveraging the stream support.stream utility method.